All right, so hey everybody, welcome to VC Talk or welcome back to VC Talk if you already know about it. Today I'm here with Andrew Rush. I'm beyond excited to be here with him. He is CEO of Starcatcher, and he's gonna tell us a little bit more about it. But a little bit of introduction about VC Talk, if you don't know it, is a podcast I recently started with the purpose to share insights from the venture capital industry, including great VCs, great founders, and operators. So thanks a lot, Andrew, for taking the time to have this chat. Please introduce yourself, and then we can get started.
Yeah, absolutely, Gio. Thank you so much for having me on the podcast. I'm Andrew Rush. I'm the co-founder and CEO of Starcatcher. Starcatcher is actually the third space company that I have the pleasure of
Yeah,
building, scaling, and so we can talk about that
yeah.
as we get going.
Yeah, absolutely. Before talking about Starcatcher, you mentioned you are a repeated founder. And we actually were involved in your previous, some of your previous companies. If you just want to touch a little bit of that on that, and how did your space journey started?
Yeah, yeah. So my technical background is actually in physics.
Okay.
When I first went to undergrad, I wanted to be a cosmologist,
Yeah.
and I was always very, very into space. And I ended up starting a company when I was an undergrad, and really, really had that entrepreneurial bug, and sought to find a career that would marry those two things up. The love of space and technology,
Hmm.
and a love of entrepreneurship. So I ended up going to become a patent lawyer
Yeah.
for a number of years,
Okay.
and that's where I actually got connected up with the first company that I had the pleasure of running, which was called Made in Space.
Yeah.
So Made in Space did exactly what it said the name in the name, which
Do
was
stuff in
manufacture
space.
off the face of the planet. Yeah, yeah. We like things that are named simply and say what they
Yeah.
do. And so Made in Space was the first company to manufacture functional objects off the face of the planet,
Hmm.
specifically through developing and fielding 3D printing technologies
Yeah.
on the space station, and then exploring how to do that elsewhere as well.
Yeah.
And Manuspace was founded in 2010,
Yeah.
and we built that company through the 2010s, which was a period of time where the venture capital and the customer markets looked very different than they do today.
Hmm.
So we grew that company almost totally organically. We
Yeah.
did end working with with VIA Venture Partners
Yeah.
to have a little bit of some secondary, a little bit of activity toward the end of that build-up, which was really amazing.
Yeah.
Uh, but really, we're able to work very closely with customers, demonstrate that you could manufacture off the face of the planet, show that
Hmm.
robotic assembly of satellites was an achievable thing,
Yeah.
and then ultimately sold that company in 2020.
Yeah, that's awesome to Redwire, right?
That's right. That's right.
Yeah, and
Yeah.
then you transition to Redwire for a period of time.
That's right. So at
Yeah,
Redwire was another really interesting company from an evolution of the space sector perspective.
yeah.
So Redwire was a private equity backed roll up,
Hmm.
where the objective was to build a mid-market space subsystems company
Yeah.
that really married companies that delivered really high quality heritage, state of the art products with companies and products and services that were more innovative, more
Hmm.
cutting edge, like the evolution of those heritage products.
Yeah.
And I had the pleasure of becoming the president and chief operating officer of
Yeah.
Redwire, and led or co-led the first 6 or 7 acquisitions
Yeah.
that occurred
Mhm.
there. We built up actually the largest independent provider of space solar arrays in the United States,
Yeah.
and did a whole lot of really great work. Put new solars on the space station, put new arrays, built new arrays for the Space Development Agency,
Hmm.
performers for many other commercial space
Yeah.
operators.
So yeah.
Yeah.
Yeah. So it seems you know a little bit what you're doing from your prior experiences. All right.
Certainly,
So
certainly have the scars,
yeah, yeah, a
to
good journey. And so coming to Starcatcher, what is the vision of the company and why you decided to start this journey, right? And why now?
Yeah. Yeah. So my professional and personal motivation is to enable people to do more in space enable people to do new things in
Hmm.
space. I grew up on this steady diet of science fiction, Star Trek and Robert Heinlein, and then also, science fact, physics and chemistry.
Yeah.
And and so that's really, it's kind of inevitable that I wound up here. And so Starcatcher really is an extension of that personal motivation, that professional motivation that I and my co-founders share. The vision at Starcatcher is to make it as easy for us to operate in space,
Hmm.
that is, as it is for us to operate on the ground.
Yeah.
And the way that we think you can have that paradigm shift, you can have that unlock, is by providing the same kinds of infrastructure in space
Yeah.
that we have on the ground anywhere people live, work, or play.
Yeah.
And specifically, that's telecommunications infrastructure, transportation infrastructure, and power infrastructure.
Hmm.
In space, we have transportation infrastructure. It's just that our roads are rockets. We
Yep.
have telecommunications infrastructure, except our telephone lines are big dishes and aces. But there is not a power grid in space.
Yeah.
Everybody goes on these camping trips. They bring their solar panels with them. When they see the sun, they charge up. When they don't, they just live off of batteries.
Hmm.
And that is really, really inefficient, and really constraining. My professional experience, the power budget is actually much harder on a mission
Yep.
than the mass or the volume budget.
Yep.
And so at Starcatcher, we're building the world's first power grid in space to give
Hmm.
satellites more energy, higher concentrations of energy and eclipse, to
Yeah.
break that paradigm and ultimately make it as easy for us to operate in space as
Yeah.
it is on ground.
Yeah, that sounds great. I mean, it's a great vision. And related to the timing, why do you think that now is the right time to build that, right? You started in 2024, I think, the inception of the company. Why do you think now is the right time and not in 5 years or 5 years prior, like in 2020? Why do you think is the right moment?
So this is the right moment to build a power grid in space because we have a confluence of technology and market.
Hmm.
We've seen the development and demonstration of laser communications terminals in space, saying, "Hey, I can beam data over long distances
Hmm.
and maintain custody of the other spacecraft that I'm going to beam this data to." And we also have seen a market evolution where we've gone from a primarily multi-orbit construct with telecommunications assets in GEO and LEO and even a
Yeah.
little bit in between to an explosion of the number of assets in space, but most of them, like 80 or 90% of them, in low Earth orbit.
Yeah.
So those satellites have gotten smaller, they've gotten more numerous, and they're all kind of geographically co-located in low Earth orbit
Yeah.
altitudes. And that has created this set of folks that all have a common need, which is that they're pretty power constrained,
Hmm.
because your average low Earth orbit satellite has like 1,500 watts of power
Yeah.
generation on board, and they're all in the same space,
Yeah.
which is LEO. And so that the combination of those factors makes a power grid in space to give those folks 10,000, 20,000 watts on average rather than
Yeah.
1,500 watts.
Yeah.
It really makes this the opportunity to do that because people aren't talking about putting giant constellations in space, they're doing it. And of course, 5 or 10 years from now, it'll be fully built out and there will be a power grid in space. So
Yeah.
because we
Yeah.
built
Yeah.
it.
Yeah, that's a great point of view. And how do you see like the space economy evolving? Because right now there's, as you mentioned, there's like a concentration of different technologies that are intensifying from also orbital data centers. I mean, we are bullish on that, and different other technologies. How do you see the space economy in 5 to 10 years? Like, because it is evolving a lot, like it's
Yeah.
accelerating a lot in these last years, right? And also a lot of capital is going into space right now, so it is attracting a lot of attention. What is your perspective on that vision?
There are three buckets for the next 5 or 10 years of space that I think are really hot to watch.
Hmm.
The first is the LEO telecommunications constellation.
Okay.
We have seen from Starlink to AST Mobile to Link Global to Amazon Leo, multiple well-funded folks
Yeah.
starting to put cell phone towers on orbit.
Hmm.
And that is amazing because it is a quantum leap for the capability that we all, can access.
Yeah.
It may actually deliver on the promise of not actually having dead zones,
Yeah.
which is a kind of a white whale for the mobile telecommunications industry. And from a space perspective, it is a demand unlimited
Yeah.
market, right? That people say, hey, like that for every couple watts you could put on you could provide additionally to a satellite, you can open up another downlink to a cell phone, and
Yeah.
that person wants high throughput, constant data
Yeah.
on their device. So like that is amazing. And we're going to see, we have already seen, we are seeing Verizon, T-Mobile, AT&T all make partnerships and drive that part of our industry forward. So like
Hmm.
that is a huge tailwind, a huge lift for us.
Yeah. Yeah.
We've seen in the last year the conversation around orbital compute go from like, yes, it'd be nice to have some GPUs on orbit to do processing and whatnot, and that's really power intensive,
Yeah.
to folks in various flavors saying we're going to have some or most or on the extreme ends all of compute be in space.
Yeah.
And that is also just an amazing moment, right?
Yeah.
We are seeing the birth of a hyperscaler in SpaceX,
Yeah. Yeah.
with the ambition there. Now, are we is SpaceX going to achieve the visions that Elon Musk is laying out on the timescale that they're laying out? Absolutely not. Because if there's one constant in this universe, it's that a timeline that Elon Musk states will not be hit. But will
He's
they
doing
do?
stuff. He's doing
Right,
stuff.
but will they get there
Yeah. Yeah.
like
Yeah.
one
Obviously.
day? Yeah,
No. No.
like
No.
like generally they do get to some version of it.
Yeah. Yeah. Yeah.
And I really hope that the orbital data centers looks more like Falcon 9 and
Hmm.
Cr- and Crew Dragon and less like Cybertruck.
Yeah.
But I really think we're going to get there.
Yeah.
Uh,
And do you think
and-
that, I mean, the whole Odyssey like thesis started because we have like a constraint of computing here on Earth, or like, I mean, we have our own thesis. I don't know if you have a perspective related to the constraint of doing data center on Earth,
yeah,
the cost of that, from operating of fixed cost, or the need to expand and have more computing. Why everything started, and people said, let's do it in space. Yeah,
yeah,
go.
yeah. I think it is a natural extension of the integration of low Earth orbit into the telecommunications tapestry of the world.
Okay.
The near term, I think a near term application for orbital data centers is actually just storing data that we access on a regular basis closer to the telecommunications node that we're using. So
Yeah.
terrestrially, it is not uncommon for the Netflixes of the worlds, the YouTubes of the worlds, and whatnot to have what are called content distribution
Yeah.
nodes based in major cities, so that all the folks there can like ping that more rapidly, and rather than ping like one monolithic server in
Yeah.
Silicon Valley, they're distributed all over the world, so it's faster and more stable.
Yeah.
As we build a global telecommunications network in space, it makes sense to co-locate that data with those cell towers in space.
Yeah.
So I think that's like an immediate term access, that just from a business perspective makes sense.
Hmm.
Um, from a the broader case of orbital data centers have access to more power, have access to better thermal, don't need as much water
Yeah.
in space as they do on the ground. Um, I think that's true. And I actually think that what we're building at Starcatcher, with a power grid that can actually, what we do is we send just clean power beams to you. Basically,
Yeah.
the part of the spectrum that solar arrays really are highly efficient at consuming, that's what we send, basically 400 to 1100 nanometers.
Yeah.
I mean, we don't send the energy that the sun sends you outside of that. And we can also increase the intensity of that beam to like the equivalent of like 5 or 10 suns of flux.
Okay.
And what that does is actually creates a low heat load power delivery beam relative to just having more solar.
Sure.
Because the more solar you put out, the more you're absorbing like not only the nice parts of the spectrum from the sun that you want to consume, but
Hmm.
also all that really nasty heat load.
Yeah.
And we, but if you have a smaller panel,
Yeah.
you're getting less from the sun, and then we are sending you that clean beam, and that
Yeah.
actually makes the business case even stronger for
Hmm.
orbital data centers
Yeah. Yeah. Yeah.
relative to what it is now.
You don't need you don't need retrofit, right? They can use their solar
That's right.
panels.
That's right.
And
Yeah.
yeah, so maybe data center in the future will be a big customer of yours, let's say.
Yeah.
So we touched on two theses. You had like a third thesis, right?
Yeah.
Related to space.
I really think on the edge of that 10 years, we will see more new uses of space. We're going to see manufacturing go and research in space go
Hmm.
from small scale onesie twosies to actual consistent like contract research organizations in space, actual
Okay.
consistent manufacturing of goods that because they were manufactured in the microgravity environment, they're better than what we
Yeah, yeah,
have
yeah.
terrestrially.
Got
I
it.
don't think like I don't think that's going to be a consistent thing in 5 years, but I do think that's going to be a big and interesting and awesome leg of the stool in
Yeah.
in the kind of 7 to 10 year kind of time frame.
Yeah, that's awesome. I think that on that, like Varda is definitely operating in that a little bit. But let's see in 10 years how it evolves. And yeah, related to Starcatcher, like execution wise, is everything going on based on the plans you guys have? I saw that you broke the DARPA record of energy transmitted. That is awesome. How stuff is going from an execution perspective, and what is the timeline you guys have?
I really believe in a hardware rich crawl, walk, run approach to technology development and enlisting your customers along the way as you're doing that technology maturation. So you're also proving out the business case to
Yeah.
them as you go. And so the pathway that we have laid out at Starcatcher has been to spend the first year or so of the company focusing on demonstrating via a series of ground demonstrations that we own the technology stack to do
Yeah.
space-to-space power beaming. And thereafter, do that same work, do that same build up, but do it in space.
Yeah.
So and I'm proud to say that's what we have done. So we in 2025 we first beamed measurable power across a football field. We went from one end zone to the other using the technology that we have developed.
Hmm.
And then in October of last year, we went to Cape Canaveral and we beat, as you mentioned, beat the DARPA world record for optical power beaming power levels and delivered over a kilowatt of energy to off-the-shelf solar arrays that were more than a kilometer down the runway at Cape Canaveral that they used to land the space shuttle on. Really,
Yeah.
really historic place, really awesome experience. We had customers actually bring hardware and we beamed energy to them. So it wasn't just like, hey, this is this cool like science experiment. It was
Yeah.
like,
Yeah.
here's the entire workflow showing people that this is what they're going to see in
Hmm.
space. Going forward now, we plan multiple space missions to prove it out first from a measurable perspective and then from a useful perspective,
Yeah.
to get to that first commercial power beaming light, as it were.
Yeah. So the plan to go in space is within this year or like next year?
This
When
year.
we
Yep.
this
Yep.
year? Got it. So the first mission is this year and demonstration of the technology in space, basically.
Yep.
Got it, got it, got it. Super cool, super cool. And no, nowadays, related to the startup, what is the biggest problem that you're trying to solve right now?
Yeah. That's a great question. For a space company, the biggest risk is almost always vendors.
Okay.
Um, like maintaining schedule, maintaining cost, maintaining the quality of what you're trying to deliver is of course like an engineering challenge. Like if it was easy,
Everybody,
already be done.
yeah,
Um, but space is a team sport, and so working well with your vendors, your stakeholders, and everything is always something you have to keep your eye on.
yeah,
Uh, so I would say that's always top of mind for us. And the other is like, look, we see this amazing moment in the space sector, but it is an ephemeral moment. And so meeting that moment, having the right folks on the team, having the customers being bought in, having capital that enables us to go
yeah.
just wide open throttle but go sanely in that way is what we're charged to do.
Yeah, yeah. That I think that on the point it covers a lot of stuff. And in terms of culture that you like to develop in the company, what is the culture that you like to develop?
Yeah. From a cultural perspective, we are a vision-driven organization, right? Like we're not here just to do cool science projects, do cool engineering products. We're
Yeah,
here
do the
to
9 to 5. I'm sorry.
exactly.
Yeah,
Yeah. We're here to make it easier for people to operate in space
yeah,
and deliver on the promise of what space can mean for humanity. And so that's really the core
yeah,
of what we do. And I believe in a very like high tempo, high communication environment, and believe deeply that it doesn't matter how many times I have said a thing, it matters how many times
yeah.
the team has heard the thing and understood the thing,
Hmm.
and likewise for everybody else in the organization. And we also really try to preach that look, like a startup is a fast-paced organization,
Yeah,
that will have growing pains, but growing pains are actually good pains. Because like when you were like 8 years old and your legs hurt because you were growing,
yeah,
well, like that sucked at the time, but it was good because it meant, hey, you're getting taller. Like
yeah, 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 yeah,
and like you're maturing. Like that's awesome. And
yeah,
so, when you go from 3 people to 40 people in like a year and a half, and then when you go from 40 to 100 in another compressed timeline,
yeah,
um, that the friction that comes with that is a friction that we're acknowledging, and that we want to, like, look to the person to our right, look to the person to our left, and say, hey, we're going to come together, and we're going to push through this, and we're going to make it better so
yeah,
that those that come after us have it easier, and that we can achieve the vision that we all are here for.
yeah. Yeah, that's awesome. I love the like vision and pushing and grow. I think it is at the core of humanity. So that is great. And in terms of potential competition, do you see anybody that could stop you from becoming the key player as a power grid in space? Do you see potential multiple players in space that power other space infrastructure? What is your vision on from this perspective?
So space is not naturally monopolistic. There are very few sectors that are.
Yeah,
And I see and I think it's best for space, for there to be more than one strong player
yeah,
in every vertical, in every sector.
hmm,
My objective with Starcatcher is to be the first and the best.
yeah,
We want to be, we want to be the biggest, highest quality power grid that exists in space.
hmm,
Uh, that doesn't mean that we don't have competitors, but it means that doesn't mean that having those competitors doesn't motivate us.
yeah.
Um, just as I honestly hope we motivate them. But we absolutely are committed to being the best and the biggest.
Yeah, like the industry standard, let's say.
Exactly.
Got it. Got it. And related to power beaming, like very brief. So you guys do space to space, but we also look into space to Earth power beaming. Do you why you decided to do space to space and not, let's say, space, obviously to empower space economy, but like there are some companies trying to do space to Earth.
Yeah.
Do you have any perspective on this? Like, is it too early, or you need more infrastructure in space to make this happen properly from an economical standpoint of view? Do you have any perspective, brief perspective on this?
I really hope that every space company is successful
Okay.
from the most basic concept to, just making more star trackers
Yeah.
to, mining unobtainium on an asteroid. Like if
Mhm.
everybody's successful, that means that the vision of space that I have and like dedicated my life to is here.
Yeah. Yeah. Yeah.
And space to ground is a technology that is a concept that has been written about in science fiction for decades. That's really, really exciting,
Yeah.
and one day will be here.
Yeah.
Um, the more immediate market for power transfer in space is to other satellites, which is why that's what we're focused on at Starcatcher.
Got it. Got it. Got it. Got it. All right. So coming toward the end of this episode, like any final thoughts or any perspective or any suggestion related to the space industry, both on the operator side or also the investor side? Do you have any final feedback?
Yeah, I mean, I think that the thing I'll leave you with here is it's really an amazing time to be in the space sector. But the fundamentals have not changed. The
Mhm.
fundamentals are you have to deliver a product or a service to people that actually enables them to do the thing that they need to do.
Yeah.
Uh, because space is an austere environment, and we utilize it after most times we've exhausted all the other ways of approaching a problem.
Yeah.
So business models that drive product and service value that solve problems or enhance capability right now
Yeah.
for extant business models
Yeah.
are where the gold is in the
Yeah.
hills.
Yeah. So solve actual real problem now, basically.
Yeah,
Got it,
exactly.
got it, got it. Awesome. Thanks a lot, Andrew. I'm very excited for you and for the future of Starcatcher. And thanks a lot for taking the time to have this chat. I really appreciate it. And yeah, wish you all the best. I mean, I'm excited to see in 1 year, 2 years where you're gonna be. So thanks a lot for taking the time. I appreciate it.
Absolutely, Gio. Thank you, and thank you for the support.
Have a good one.
See you.
Bye bye.